Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 2nd, 2025, just 2 days ago. It shows how a smaller model can generate answers 27 times faster with only a 4.6% drop in accuracy. The paper is titled NaturalThoughts, Selecting and Distilling Reasoning Traces for General Reasoning Tasks. And it suggests a new way to balance accuracy and efficiency in smaller models. This paper investigates how to best select data to teach reasoning skills, finding that more data is actually better. So let's look at the first figure to see this in action. The process of a large model teaching a smaller one is called distillation. Here, the teaching material is made of reasoning traces, which are the step-by-step thought processes of the teacher model. These charts plot model accuracy against the number of these reasoning traces used for training. The lines clearly show that performance climbs as the amount of data increases, directly challenging that less is more idea. And even better, selecting specific types of data, like for diverse reasoning strategies, provides an even bigger boost. Okay, so how can we make this process more efficient? This next chart explores that by mixing two types of training data. There's System 1, which is just the final answer, very fast, and System 2, which includes the full reasoning trace, much slower. You can see accuracy plotted against response length. The green line, representing a difficulty mixing strategy, is the real breakthrough here. It intelligently combines both simple and complex examples and actually achieves higher accuracy than the purely step-by-step System 2 method while being significantly faster. Building on that idea of mixing data, this diagram shows the whole workflow. It's a three-step process. First, they generate reasoning traces, those step-by-step thoughts, using a powerful teacher model. Then, another model annotates these traces, which just means adding helpful labels to create the main NaturalThoughts dataset. Second, they filter this large collection to create specific subsets, like selecting only for difficult problems. Finally, in the distillation step, they use these curated subsets to efficiently teach a smaller student model how to reason. So this table really puts the numbers to that workflow. We're looking at the performance of a student model, Llama 3.1 8B Instruct, on several challenging reasoning benchmarks. The main takeaway is in the scale section. As the training size grows from 1,000 to 500,000 examples, performance consistently improves. But what's really interesting is how they select the data, choosing examples based on diverse reasoning strategies or difficulty, especially using a method called Models Disagree, which selects questions where teacher models get different answers, provides the biggest performance boost. And this final table really quantifies that accuracy versus efficiency trade-off. It compares models trained on just final answers. System 1, with those trained on full reasoning. System 2, it also introduces different inference modes, like no think for speed or think for deep reasoning. The standout result is the difficulty-based mixing strategy. Look at the think column. This mixed model achieves 38.9% accuracy, which is actually better than the model trained only on full reasoning. This means that teaching a model when to reason deeply makes it a better thinker overall. So, to wrap up our discussion on NaturalThoughts, it really challenges the popular less is more idea in AI training. The key takeaway is that for teaching general reasoning, more high-quality data is simply better. And it's not just about quantity. The type of data is crucial. Selecting for diverse reasoning strategies, which are the different ways a model might approach a problem, and focusing on difficult questions provides the most efficient path to a smarter student model. This approach of intelligently mixing simple and complex examples is a powerful new tool. Thanks for tuning in to the AI Research Roundup. See you next time.